Welcome everyone. Today, we are unpacking the foundational concepts of generative AI. We will cut through the hype and focus squarely on understanding how generative AI differs from the traditional AI systems you might already be using. Let us get started. Welcome to our first slide. Before we contrast generative AI with other types of artificial intelligence, we must establish a baseline. What exactly is AI? At its core, AI refers to software systems capable of analyzing data, recognizing patterns, and making decisions or predictions that previously required human intelligence. As business leaders, you do not need to focus on the underlying math. Your focus should be on the outcomes. The basics of modern AI are built on data science and machine learning, which allow systems to automate tasks that benefit from human-like judgment. Why does this matter? Because AI delivers reliable, repeatable value through faster insights and more efficient operations. How does it do this? By utilizing a toolbox of capabilities, ranging from predictive forecasting to descriptive summarization. In our deep dive, we recognize that AI is not a single monolith, but a versatile collection of tools designed to solve specific real-world challenges. Let us look at the flowchart on your screen. This diagram breaks down the umbrella term of artificial intelligence into its foundational pillars. At the top, we have artificial intelligence, which branches out into data science, machine learning, and deep learning. Notice how machine learning flows directly into predictive analytics. This is because ML techniques allow systems to learn from data and make future predictions. Meanwhile, deep learning, which uses layered neural networks, flows into pattern recognition, excelling at analyzing unstructured data like images and audio. This visual helps us understand that AI relies on these interconnected disciplines to function as a comprehensive problem-solving toolkit for the modern enterprise. Now, let us examine traditional AI, which we can think of as the analytical engine of your business. What is traditional AI? Historically, this branch of AI has focused on building custom models designed to make specific predictions or classify information. The basics lie in machine learning, where algorithms learn from existing data to improve their performance over time without needing explicit programming. Why do organizations use it? Primarily for numerical prediction, classification, and clustering, such as forecasting sales demand or detecting anomalies in financial transactions. How is it implemented? It requires a collaborative lifecycle where data scientists prepare clean data and train the model, while developers integrate it into business systems for real-time inferencing. For our deep dive, think about credit card fraud detection or email spam filters. These models are highly trained to recognize specific, historical patterns and apply a label of fraud or spam to new data. Take a look at this process flow for traditional AI. We start on the left with historical data, which is meticulously cleaned and fed into the model training phase. This results in a deployed custom model that is highly specialized for a single task. When new user input is introduced to this deployed model, it processes the data and outputs a specific prediction or classification highlighted here in pink. It does not create anything new, it simply evaluates the input against what it has learned from the past to give you a definitive answer, like forecasting a sales trend or flagging a transaction. Moving to our third slide, we introduce generative AI, the creative engine. What is it? While traditional AI analyzes data, generative AI goes a step further by producing entirely new content, including text, images, audio, and functional code. The basics involve using massive, pre-trained foundation models like large language models that have ingested internet-scale data and operate based on your natural language prompts. Why is this revolutionary? It allows businesses to automate content generation, draft marketing copy, and summarize lengthy documents in seconds, vastly augmenting human creativity. How does it achieve this? These models encapsulate deep linguistic relationships, allowing them to reason over your input and generate highly relevant responses. For our deep dive, we must recognize the transformer architecture powering these models. Transformers handle data in parallel and maintain incredible contextual understanding across long conversations or documents, making them uniquely suited for enterprise workflows. Let us trace the path of generative AI on this diagram. Unlike traditional models that require raw numerical data, this workflow begins on the left with a natural language prompt. You speak to it just as you would a colleague. This prompt flows into a pre-trained foundation model, which utilizes contextual reasoning to understand the nuance of your request. The system then moves to novel content generation highlighted in blue. Finally, it outputs something entirely new, such as a drafted email, a block of software code, or a marketing image. It is an engine of creation, not just an engine of analysis. Slide 4 highlights the crux of our training today, the core difference between the two technologies. What is the fundamental difference? Traditional AI is analytical, focusing on predictions and classifications, whereas generative AI is synthetic, producing completely novel outputs. The basics show a shift in architecture. Traditional AI relies on highly specialized, custom-built models, while generative AI leverages incredibly versatile, pre-built foundation models. Why must leaders understand this? Because you must map the right tool to the right problem. Use traditional AI to predict customer churn, but use generative AI to draft the email attempting to win that customer back. How does this change our workflow? It shifts the developer focus from training models from scratch known as MLOps to generating content using pre-trained models known as LLMOps. In our deep dive, note that this also shifts your cost drivers. Instead of massive upfront training costs, generative AI costs are driven by inference, or the token-based usage of the model via prompts. This visual perfectly captures the fork in the road for AI adoption. From the central AI problem space at the top, we branch into two distinct paths. On the left, if your goal is analysis and prediction, you choose traditional AI, which utilizes custom-built models to output labels and numbers, like risk scores. On the right, if your goal is creation and synthesis, you choose generative AI, leveraging pre-trained foundation models to output text, code, or media. By understanding this split, you can immediately identify which technology stack is required when a new business challenge crosses your desk. Let us go deeper into the types of generative AI models on slide 5. What are they? Generative AI is not a single model, but a family of model types optimized for different content formats. The basics include large language models, or LLMs, which master natural language, and code models, which are specifically trained on programming languages to assist developers. Why do we have so many types? Because selecting the correct model ensures you balance performance with cost. You would not use a heavy multimodal model for a simple text summarization task. How do these specialized models work? Diffusion models, for instance, translate text prompts into high-quality images, while the latest multimodal models can ingest audio, images, and text simultaneously to provide rich, interactive assistance. For our deep dive, remember that while these models are pre-tuned for general use, they can be fine-tuned with your specific enterprise data to master niche, domain-specific tasks, offering incredible competitive advantage. Look at the model taxonomy diagram displayed here. At the top, we have the broad category of generative AI models. It breaks down into 4 primary pillars. First, large language models, which drive chatbots and summarization tasks. Second, code models, empowering developers with code completion and debugging. Third, diffusion models, which are vital for creating marketing visuals and product designs from text prompts. Finally, multimodal models, the newest frontier, enabling interactive assistants that can see, hear, and read all at once. This structure helps you map your specific business requirement directly to the ideal model architecture. Slide 6 tackles the steering wheel of generative AI, prompt engineering. What is it? It is the deliberate process of crafting natural language instructions to guide the AI toward a highly specific output. The basics are simple but crucial. An effective prompt must include a clear goal, relevant context, specific data sources, and formatting expectations. Why does this matter so much? Because generative models do not inherently know your intent. They rely entirely on the context you provide. Poor prompts result in hallucinations, irrelevant data, and wasted time. How do we master this? While business users focus on clear instructions, developers utilize advanced techniques like few-shot learning, giving them model examples within the prompt to ensure output consistency. In our deep dive, we introduce Retrieval Augmented Generation, or RAG. RAG automatically grounds the AI by pulling trusted enterprise data and injecting it into the user's prompt behind the scenes, ensuring the AI's response is factually accurate and highly relevant. This flow diagram illustrates the anatomy of a successful prompt. We begin on the left with user intent, which is translated into a draft prompt. At the critical decision node, we ask, add context. If we fail to add context, we take the bottom path leading to generic output risk, where hallucinations occur. However, if we take the top path, we inject enterprise data, often using RAG methodologies. This creates an optimized prompt, which is fed into the generative AI model. The result, highlighted in green on the right, is a highly accurate and relevant output. Context is the absolute key to unlocking generative AI's value. To solidify these concepts, Slide 7 presents a real-time, highly impactful use case, the hybrid AI solution. What is this? It is the strategic combination of traditional predictive AI and generative AI to create end-to-end, autonomous workflows. The basics involve using traditional AI to identify a numerical trend or problem, and generative AI to create the content needed to address it. Why do this? To achieve unprecedented operational efficiency, moving from data analysis to execution without human bottlenecks. How does it work in practice? Imagine a global retailer. A traditional machine learning model detects an anomaly and predicts a severe supply chain delay for a popular product. Instantly, an AI agent takes that prediction and triggers a generative AI model to draft urgent outreach emails to alternative suppliers, while simultaneously generating localized marketing copy to promote in-stock alternatives to customers. This deep dive into agentic workflows shows how we turn an abstract numerical prediction into immediate, creative business action at scale. Let us walk through the sequence diagram to see the hybrid workflow in action over time. First, retail data feeds into our traditional ML model, which excels at analysis. The ML model detects an anomaly and sends a delay prediction alert to our central AI agent. Now the magic happens, the agent acts as an orchestrator. It sends a prompt to the generative AI model to draft supplier outreach emails, which the Gen AI quickly returns. Immediately after, the agent prompts the Gen AI again, this time to rewrite ad copy for items that are actually in stock. Finally, the agent updates the enterprise systems. We move seamlessly from traditional prediction to generative creation. We conclude on Slide 8 with strategic adoption. What does this mean? It means strictly aligning your specific business problem with the correct AI engine. The basics are clear. If you need to forecast sales, detect fraud, or classify data, you must build or buy traditional machine learning models. If you need to draft reports, summarize documents, or write code, you deploy generative AI. Why is this distinction so critical? Because applying a generative model to a strict mathematical forecasting problem can lead to hallucinations, wasted compute costs, and severe business risk. How do you choose? Always ask your team, does this use case require mathematical precision, or does it require creative synthesis and language understanding? In our final deep dive, remember that regardless of which AI type you choose, you must secure your foundation. Establish robust AI governance, ensure your enterprise data is clean and ready, and define your ROI metrics before a single model is deployed into production. Thank you for your time. Our final flowchart serves as your ultimate decision-making tool. You start at the top by identifying the business problem. You immediately hit a decision gate. Is the goal content or prediction? If you need prediction or classification, you route left to traditional AI, which powers predictive analytics. If your goal requires content, text, or summarization, you route right to generative AI, enabling drafting, code, and visuals. Notice that regardless of which path you take, both converge at the bottom box, apply governance, and monitor ROI. Technology choices may differ, but the necessity for responsible AI and measurable business value remains absolute across the board.